Hey everybody. I think I'm on to the last three I'm going to make today. So this one's going to be a one mean hypothesis test, and we're going to do problem 15 from chapter 20 homework. So let me pull that up. I closed my homework when I opened StatCrunch. Okay. All right, chapter 20 homework. Here we are. Okay, all right. So, talking about 15 here. So you got to match some plots to some data in 15. And this is why I want to be real careful, it's important to me that we do this one. Okay, so I've just opened the workbook and I copied this data to the clipboard and pasted it in. I could have entered the values as well. So to use this basic stats worksheet and get our values correct, because like our interquartile range is negative, like things aren't making sense. So we've got to sort this data from least to greatest. And I've talked about this in the basic stat 1 video, but I don't think I mentioned. So if you're on the home tab, you got to hit the data tab here, hit sort, and then by default, it's sorted correctly, or it sorts the way you want it to. So there we go. That fixes our interquartile range and our first and third quartiles. We have average, standard deviation, number, median-based stats here, interquartile range, and the range total. Yeah, all sorts of wonderful crap, going on here. Okay, so what do you do now that you're here? How do you generate these histograms? So if you wanted to, you can insert a recommended chart, and you want something like a clustered column. Not great, right? This is something Excel doesn't excel at. Let's look here. Maybe we want, so if you've gone ahead and installed the analysis tool pack, you will have access to these histograms here, but in general you don't. And what you'd have to use is some sort of 2D column chart. And that's a pain. It doesn't give you what you want, like hardly at all. It's ridiculous. So what do you do? What do you do? This is a must-do StatCrunch. Yeah, not everybody likes it, but this is a must-do StatCrunch. Command copy, command paste. Okay, so I just want these guys and these guys, right? So what do? Over in StatCrunch, graph, histogram, var1. And while we're here, let's mark the median and mean. Yeah, that'll do. So I hit var1 there, and I want to mark the median and mean. Okay, that's what it looks like for us, for our graph scale. So, ours starts at 40, edit, oops, wrong place. Hit this little menu here. We're going to edit the x-axis so that the minimum is 0. Maximum is 100, so it looks like the graph over there, right? And then hit this again, edit the y-axis, and make our maximum 10. I'm just matching the graph scales from over here, right? Okay. So now it's easier to pick it out, right? That's really all I was doing there was yeah, I can just fit it all. Okay, now then. Yeah, so yeah, we could have picked that, right? We could have picked that. They have slightly more bins than we do. If we want to Didn't know that was there. Edit. Edit, rows per page, basic 7 colors, percent count. Bin width, that's what I want to look for. So they have more bins than we do, right? More bins. So if we wanted to be just sure that this was the right thing, we have 1, 2, 3, 4, 5 bins. Okay, so let's make it 7 bins. Does that give us no better? No. Let's take it to 9. Okay. So yeah, we're starting to get more of what they're seeing. Of course, we would have to change our x-axis again to see it perfectly. Let's see, it looks like their bin width is 2.5. So let's just make it exactly 2.5. No, their bin width was 5. So what I'm doing there is I'm looking at the scale here, 20, 30, 40, 40. Yeah, it looks like 2 per 10. So some of these you could say number of bins, and that's real nice. That's real effective. But yeah, we'll have to do that. And there we go. We get the spitting image. So yeah, get good at changing graph scales, right? How do we get a normal probability plot? A normal probability plot is the same thing as a QQ plot. Part 1. Compute. Hey. So yeah, it's got the normal quartiles and the time in seconds up here. So I mean, we can of course change our graph scales some more, but I think we can spot the one it is, right? Okay. So then randomization condition is met because the normal probability plot, like these are the horizontal position is where it should be. So the red line is where it should be relative to its z-score position, right? And this is where it actually is as a calculated, or it actually is, right? And so what we see is that it's generally following this line that would indicate perfectly normally distributed. So yeah, we can call that pretty darn good. PDQ, as you say. Okay, so randomization condition is met because the normal probability plot is relatively straight with a big outlier over here. Okay, cool. So that is done, and you got to draw your plots in StatCrunch, and you do that with graph, histogram, and graph QQ plot. I mean, you could also take a multi-plot, I guess, but no. Let's not make it complicated. Graph, histogram, graph, QQ plot, in and done, right? Okay, so step one. We've confirmed that our conditions for randomosity are met. All right, so let's formulate a hypothesis. What are we doing here? We're doing some rats running in mages. These are the time they took it to run. And we're using 0.05 as our alpha level, or our cutoff p-value. Same difference, right? Okay. So we're going to test the time for maze runtime is equal to 60 seconds, and we're going to draw a conclusion. So you choose the correct and null hypothesis. Mean completion time is denoted by mu. Okay, so if we're trying to test for 60 seconds, we will assume h naught is equal to 60, and that H naught, mu is equal to 60. The alternative, mu is not equal to 60, right? That's what we're looking for here. We're not convinced that it's greater or less, so we're going to say not equal. Okay. Good thing we know all that, because now we can pop over to t-CIHT with 1 mu. And we can say to ourselves, the null is that the time to run this maze is equal to 60. We're going to test for not equal to. So you can get this part from basic stats, right? Let's look over here. Yeah, there's the numbers we need. There's our, let me just copy. I need an average, I need a S standard deviation, and I need an N, right? Those are all important things to have for the T confidence interval hypothesis testing. Okay, so yeah, I'm just gonna paste that in where those are, hit my values only button again. Yeah, okay, so this will make things a little bit quicker. All right, what is my N? My N is equal to 18, enter. What is my unknown sigma? That is equal to standard deviation, enter. Okay. My X bar from my sample. It looks like I just did this problem. Yeah, okay, that's what it is, right? So our t-scores don't match. I'm getting negative 2.35, not 3.8. Let's look at what this is. Plus or minus 3%. So I would have answered negative 2.35, and this is negative 2.38 plus or minus 3, so I would have just made the rounding error, but that's not what I want to see from this kind of thing here. So let's investigate. Are my p-values close? My p-values are not close. Okay, so something's different about this. I have to figure out what it is. Mu is equal to 60, mu is not equal to 60. Let's see, unknown sigma, estimate, n is 18. Is n in fact 18? 1, 2, 3, 4, 5, 6 times 3 is 18. Guys, this is really lame. I don't know why they're doing this to us. Let's go back over to basic stat 1 and see if we missed anything there. Okay, this is we randomized the numbers issue again. Damn it. So let me just see if I copy this to clipboard. Okay, the answers didn't change. Paste that in there. Highlight this, hit data, sort. Nice little review of what we've already done there. Okay. So these are my values I take over to this tab. I will paste them here with keeping values only. Okay. So that is definitely 18. This is just a touch different. All right. Yeah. All right. So now we're matching. We're matching right up. Okay. Yeah. So yeah, that was a show answers randomized numbers issue. I'm going to leave that in. I could hide my mistakes from you and stuff and try to pretend like I'm always perfect, but I think that's good to see. Like something didn't quite make sense. It wasn't matching the answers, and I just carefully troubleshooted, right? I checked all of these numbers. They were all right. So next I moved back one step. I said, is my data correct? And I found that it wasn't quite correct. I specifically zeroed in on the 52.5 value. Yes. Hmm. Hmm. Oh, yes, there it is. There it is. Sort. Oh, it's not grabbing that top one. Sort. Okay. There we goes. There we goes. There we goes. Okay. So yeah, that fixed it. That fixed it right there. Let's see what else could have been a dealio with this problem. Okay. I'm just nervous now. I'm gonna check these one more time. Values only. Something really weird just happened there. Yeah, that's not what I wanted to happen there. Okay, but our values did not busy up there, right? So we're good to go. Okay, so that was a quick double, triple check on that, and we're good to rock. So call it good. I know there's lots of videos that have hypothesis testing going on, but it's kind of a complicated topic, and I'm comfortable just putting a bunch of different examples out there. I feel like that might be the better way to get at these things. Okay, so one for two p's, two proportions, and one for two means. And then I'm going to call it good. We'll see how much extra credit you guys can get telling me stuff I missed. All right, thanks so much, everybody. Coming at you with two more.